Dear students, welcome. This is our 11th class on statistics. Today, I shall try to solve these three problems. Question number 9, 10 and 11. See the question number 9. A body of weight W rests on a smooth inclined plane of inclination theta. Inclined plane. Suppose this is horizontal. It is inclined plane and inclination is theta. Find the horizontal force applied. Horizontal force required to keep the body in equilibrium. Suppose P, this is the horizontal force, and W is the weight of the body, and R is the normal reaction. R is the normal reaction. This and these two are parallel lines, therefore this angle is theta. This angle is theta means what will be this angle? 90 degree minus theta. Consequently, this angle is equal to theta. Consequently, this angle will be let R be the normal reaction of the plane. Reaction of the plane. Let R be the reaction of the plane. And let P be the horizontal force. And let P be the horizontal force applied on the body to keep the body is in equilibrium. Now, this is a body, the weight of the body is W. The three forces P, R and W keep the body in equilibrium. Now, since the forces P, R and W are in equilibrium. Therefore, by Lami's theory, we get P divided by magnitude P divided by sine of this angle. What will be this angle? This angle will be equal to, from this and this it is 180 degree, 180 degree minus theta. This angle will be equal to 180 degree minus theta. Sine 180 degree minus theta. Magnitude of each force is proportional to the sine of the angle between the other two. R divided by sine of angle between P and W is sine 90 degree. It is sine 90 degree. This is equal to W divided by sine angle between P and R. It is 90 degree plus theta. Sine 90 degree plus theta. Sine 90 degree plus theta. This means you will get P by sine theta equal to R by 1 equal to W divided by, it is cos theta, W divided by cos theta. This means P equal to W tan theta, R equal to W sec theta. You see, P equal to W sin theta by cos theta, W tan theta, R equal to W sec theta, 1 by cos theta is sec theta. Therefore, this is the normal reaction of the plane, and horizontal force applied is this. Horizontal force applied is W tan theta and reaction is W sec theta. Therefore, question number 1 has been solved here. We have solved the question number 1. Now, try to solve the question number 10. What is it? A body of weight 30 lbs. A body of weight 30 lbs is suspended by two strings of length 3 and 4 feet attached to 2 points in the same horizontal line, distance 5 feet. Same horizontal line, distance 5 feet. It is a horizontal line. Attached, suppose this. O. The body of weight W equal to 30 lbs. OA, the tension of the string OA is T1, suppose tension of the string OB is T2. OB is T2. Suppose there let OA and OB be the strings of length 3 feet and 4 feet respectively. That is OA equal to 3 feet, OB this is equal to 4 feet, these are two strings, AB equal to 5 feet, AB equal to 5 feet. Let these are two strings, OA and OB are the strings. Let the tensions of the strings OA and OB be respectively T1 and T2. Let the tensions of the strings OA and OB be T1 and T2. T1 and T2. Now, OA is equal to 3 feet, OB equal to 4 feet, AB this is equal to 5 feet. AB is equal to 5 feet. Distance 5 feet apart. OA square plus OB square equal to 3 square plus 4 square. This is equal to 5 square. Definitely it will be 9 plus 16, 25 equal to 5 square. This is equal to AB square. Therefore, AOB, this angle AOB, therefore AOB, this is equal to 90 degree. AOB, this angle will be equal to 90 degree. It is 90 degree. Right? This angle is equal to 90 degree. Let this angle is equal to theta. Suppose this is equal to theta. Let OBA, this is equal to theta. OBA equal to theta. Now, this is the horizontal line. These are two parallel lines, therefore this angle will be equal to theta. This angle will be equal to theta. If you put here, this angle will be 90 degree minus theta, and consequently this angle will be equal to theta. This angle will be equal to theta, right? This angle is equal to theta. These two angles, T1, T2, this angle will be equal to theta. Now, sin theta. What is sin theta? Perpendicular by hypotenuse OA by AB. OA by AB equal to 3 by 5 cos theta equal to OB by AB equal to 4 by 5. O is equal to 3 and OB equal to 4 by 5. Therefore, we have got sin theta is equal to 3 by 5. 3 by 5. And cos theta equal to 4 divided by 5. Sin theta is equal to 3 by 5. Cos theta, this is equal to 4 by 5. Now, the three forces are in equilibrium. Now, the three forces acting at O, T1, T2 and W, which is equal to 30 amperes, acting at O are in equilibrium. Acting at O are in equilibrium. Therefore, by Rame's theorem, by Rame's theorem, we get T1 divided by angle between T2 and W. What is angle between T2 and W? This angle is 90 degree. This is theta. 90 degree plus theta. Sine of 90 degree plus theta. Sine of the angle between the other W. Sine of angle between T1 and T2, sine 90 degree. This is equal to T2, magnitude of the force T2, equal to sine of the angle between T1 and W. T1 and this is 180 degree minus theta, 180 degree minus theta. It will be definitely sine 180 degree minus theta. This means T1 divided by, it is cos theta, equal to W divided by 1, equal to T2 divided by sin theta. T2 divided by sin theta. This means T1 equal to, this means that T1 equal to W cos theta. W cos theta means this is equal to 30 into cos theta is equal to 4 by 5. 4 by 5 LBS equal to 624 LBS. 24 LBS. T1 is equal to this. T2 is equal to W sin theta. T2 equal to W sin theta. This is equal to 30 into sin theta means 3 by 5. It is 6 equal to 18 LBS. Therefore, the tension T1, magnitude of T1 is 24 and it is 18. T2 is 18. Perhaps you have understood this one. find the tensions of the strings. We have applied Lami's theorem in both the problems. If three forces acting at the point are in equilibrium, then magnitude of each force is proportional to the sine of the angle between the other two. This theorem has been applied here. We have applied Lami's theorem. Now try to question number 3. Solve question number 3. Three forces acting at a point are in equilibrium. It is given that three forces acting at a point are in equilibrium. If they are proportional to 1 root 2, three forces acting at a point are in equilibrium. Acting at a point are in equilibrium. Suppose try to solve number 1. They are proportional to 1 root 2. Let the three forces acting at a point, acting at the point OC, acting at the point being B, PP and twice P, PP and root 2P, PP and root 2P. We have to find the angle between the forces, inclination to each other. Let the angle between P and P be alpha 1. Let the angle between P and root 2P be alpha 2. Let the angle between the forces root 2P and P be alpha 3. Be alpha 3. We have to find the values of alpha 1, alpha 2 and alpha 3. Three forces acting at a point are in equilibrium. This means that the magnitude of the resultant of two forces acting in one direction should be equal to the magnitude of the third force acting in the opposite direction. Acting in the opposite direction. Definitely, the magnitude of any two forces, P and P, suppose magnitude of the resultant of P and P should be equal to the magnitude of the third force acting, magnitude of the third force, and it should act in the opposite direction. The two forces, these two forces are acting at the point this. Their resultant will be acting along in this direction, so that this is a straight line. This is a straight line. The resultant of this and this should be in the straight line to the third force, but acting in the opposite direction, and the magnitude should be equal to same. Then the two forces will be in equilibrium. Then the three forces will be in equilibrium. You may write here, since the three forces acting at O are in equilibrium, therefore the resultant of any two forces, should be, equal and opposite should be equal and opposite to the third force. Equal and opposite to the third force. Therefore, the resultant of any two forces should be equal and opposite to the third force. Equal and opposite to the third force. Therefore, root 2p opposite, therefore root 2p square equal to p square plus p square plus twice p into p cos alpha 1, it will be cos alpha 1. This means twice p square equal to twice p square plus twice p square cos alpha 1. This means twice p square cos alpha 1 equal to 0. This means cos alpha 1 equal to 0 equal to cos 90 degree. This means alpha 1 is equal to 90 degree. Therefore, the inclination between P and P, between the forces, P, inclination between the forces P and P is 90 degree. Is 90 degree. This is equal to 90 degree. Again, P and root P is alpha 2. Their resultant will be equal to minus P whole square equal to P square plus root 2P whole square plus 2 times of P into root 2P cos alpha 2. This means P square equal to P square plus twice P square plus 2 root 2P square cos alpha 2. This means twice P square plus 2 root 2P square cos alpha 2 equal to 0. This P square will be cancelled. This means twice P square 1 plus root 2 cos alpha 2 should be equal to 0. This means 1 plus root 2 cos alpha 2 equal to 0 means cos alpha 2 equal to minus 1 by root 2 means cos alpha 2 equal to minus 1 by root 2. Cos alpha 2 equal to minus 1 by root 2. 1 by root 2 equal to minus cos 45 degree. This is equal to cos 180 degree minus 45 degree. You may write. This means this is equal to cos therefore alpha 2 equal to 135 degree. Similarly, alpha 3 should be equal to also 135 degree. Therefore, the inclinations, required inclinations are 90 degree, 135 degree, 135 degree. Therefore, the required inclinations are. Therefore, the required inclinations are 90 degree, 135 degree, and also 135 degree. 135 degree. Number 1, we have proved number 1. Thus, in a similar way, try to solve number 2. Root 3 plus 1, the forces are root 3 plus 1, root 3 minus 1, root 6. Here the forces are proportional to these. If root 3 plus 1 p and another one will be equal to root 3 minus 1 into p, and the last one will be root 6 into p. The pp will be cancelled. Therefore, you may write that the process are root 3 plus 1, root 3 minus 1, and root 6, like that. Let p1 equal to root 3 plus 1, p2, the process p2, root 3 minus 1. Suppose the process p3 equal to root over 6. Let the angle between root 3 plus 1 and root 3 minus 1 is, suppose it is alpha 3. Let angle between root 3 minus 1 and root over 6 is alpha 1, and angle between root 3 plus 1 and 6, root 6, is alpha 2, means it is p1 and p2. Angle between p1 and p2 is alpha 3. Angle between p2 and p3 is alpha 1. Angle between p3 and p1 is alpha 2. This. Just as before, you may write minus root 6 whole square should be equal to root 3 plus 1 whole square plus root 3 minus 1 whole square plus 2 times of root 3 plus 1 into root 3 minus 1 into cos. Angle between this is alpha 3. The angle between this is alpha 3. And it should be equal to 6, equal to, it is of the form a plus b whole square plus a minus b whole square, 2 times of a square plus b square, 2 times of root 3 square plus 1 square, 2 times of a square plus b square, plus 2 times of, it is a plus b into a minus b, a square minus b square, a square minus b square, into cos alpha 3. This means 6 is equal to 2 into 3 plus 1, plus 2 times of 3 minus 1 into cos alpha 3. This means 6 equal to 8 plus 4 cos alpha 3. This means minus 2 equal to 4 cos alpha 3. This means cos alpha 3 equal to minus 1 by 2. Cos alpha 3 equal to minus 1 by 2. Alpha 3 equal to minus 1 by 2. This you may write here. Cos alpha 3 equal to minus 1 by 2 equal to minus cos what is this? 1 by 2 means sin 30 degree means cos 60 degree. Cos 60 degree. (180 degree minus 60 degree). This is equal to cos 120 degree. Therefore, alpha 3 equal to 120 degree. Alpha 3 is equal to 120 degree. Cos 120 degree. In the previous questions, you see the sum of the angles is 130 plus 35 plus 135. 270 plus 90, 360 degree. The total answer, total sum should be equal to 360 degree. This angle is 360 degree. Alpha 3 is equal to 120 degree. Now, similarly, minus root 3 plus 1. Minus root 3 plus 1 whole square equal to root 3 minus 1 whole square plus 2 times of root 3 minus 1 into root 6 cos alpha 1. Cos alpha 1. Root 3 plus 1 whole square, root 3 minus 1 whole square. Oh, I am sorry. The root 6 whole square should be also here. Root 6 whole square. Since r square is equal to p square plus q square plus twice pq cos alpha. 2 times of root 3 minus 1 into root 6 into cos root 3 minus 1 and it is alpha 1, cos alpha 1. This means root 3 plus 1 whole square minus root 3 minus 1 whole square should be equal to 6 plus 2 times of root 3 minus 1 into root over 6 cos alpha 1. A plus b whole square minus a minus b whole square should be equal to 4ab. 4ab root 3 equal to 6 plus 2 times of root 3 minus 1 root over 6 cos alpha 1. I am writing here. This means 2 root 3 should be equal to 3 plus divided by 2 divided by 2 cos alpha 1. This means 2 root 3 should be equal to root 3 whole square. Root 3 minus 1. It should be root 2 into root 3 cos alpha 1. Root 2 into root 3 cos alpha 1. This means root 3 cancelled from all sides. 2 equal to root 3 plus root 3 minus 1 into root 2 cos alpha 1. This means cos alpha 1 should be equal to 2 minus root 3 divided by root 3 minus 1 into root 2. Root 3 minus 1 into root 2. This is equal to 2 minus root 3 plus 1 should be equal to root 3 whole square minus 1 square. Root 3 whole square minus 1 square into root 2. From this should be equal to 2 root 3 minus 3 plus 2 minus root 3 divided by 3 minus 1 means 2 root 2 should be equal to root 3 minus 1 divided by 2 root 2. Root 3 minus 1 divided by 2 root 2 means cos alpha 1 equal to, means again I am writing here, cos alpha 1 equal to cos alpha 1 equal to root 3 minus 1 by 2 root 2. This is equal to root 3 by 2 1 by root 2 minus 1 by 2 1 by root 2. You may write this is equal to cos 30 cos 45 cos 30 cos 45 degree minus sin 30 sin 45 degree. This is equal to cos 45 degree plus 30 degree. You may write like this. This is equal to cos 75 degree. 75 degree. Cos 75 degree. This means alpha 1 is equal to 75 degree. Alpha 1 is equal to 75 degree. Therefore, alpha 1 should be equal to 75 degree. Now, alpha 2. Alpha 1 equal to 75 degree. Cos A cos B minus sin B. Yes. Now, I am going to find alpha 2. You may write alpha 2. What is alpha 2? 1 is 120 degree plus 75 degree. 360 degree minus, it will be 360 degree minus 75 plus 120. Plus 120 should be equal to 360 degree minus 5 195 degree. This is equal to 5 6 160. That angle should be equal to 165 degree. Let us try to solve in this way. Again, minus root 3 minus 1 whole square should be equal to root 3 plus 1 whole square plus root 6 whole square plus 2 times of root 3 plus 1 into root 6 cos alpha 2. You may write like this. This is equal to cos alpha 2. This means minus root 3 plus 1 whole square minus root 3 minus 1 whole square. You may write like this. Should be equal to 6 plus 2 times of root 3 plus 1 into root 6 cos alpha 2. Cos alpha 2. This is equal to minus a plus b whole square minus a minus b whole square should be equal to 4ab. 4 root 3 should be equal to 6 plus 2 root 3 plus 1 root over 6 cos alpha 2 divided by 2 minus 2 root 3 equal to 3 plus root 3 plus 1 root 6 cos alpha 2. Now divide by root 3 should be equal to root 3 plus root 3 plus 1 into root 2 cos alpha 2. Cos alpha 2. Cos alpha 2. This means cos alpha 2 equal to minus 2 plus root 3 divided by root 2 root 3 plus 1 or minus 2 plus root 3 to root 3 minus 1 root 2 root 3 whole square minus 1 square. You may write like this. Should be equal to minus 2 root 3 plus 3 plus minus 2 minus root 3 divided by root 2 3 minus 1 root 2 3 minus 1. This is equal to minus, you will get 1 plus root 3 divided by root 2 into 2. Root 2 into 2. Root 2 into 2. Now, this means cos alpha 2 equal to minus root 3 by 2 into 1 by root 2 plus 1 by root 2 plus 1 by 2 1 by root 2. You may write like this. You may write like this. This is equal to minus cos of it is 30 degree. It should be cos of 45 degree plus sin 30 degree sin 45 degree should be equal to cos A cos B plus sin A sin B, cos A minus B, 45 degree minus 30 degree. 45 degree minus 30 degree. This is equal to minus cos 15 degree. This is equal to cos 180 degree minus 15 degree. Cos 180 degree minus 15 degree. This is equal to cos 165 degree. This means alpha 2 is equal to 165 degree. Therefore, the angle between the three forces will be 165. We have already calculated here, this like this. 120, 75, and 165. Therefore, inclinations are required inclinations are 120 degree and it is 75 degree and 165 degree. Inclinations are these. Required inclinations are 175 plus 165 plus 75, 170 plus 70, 240, 240 plus 360. The sum of the angles should be equal to 3. Sum of the angles should be equal to 360 degree. We have solved these three problems. Let us try to solve one more problem. Let me you see the question. Can a particle be kept at rest by three forces acting on it such that the magnitude of the forces are like this? You see, three forces are in equilibrium or they are at rest. If the three forces can be represented in magnitude and direction by the three sides of a triangle taken in order, then by the law of triangular forces, the three forces are in equilibrium. And another one is this: suppose the three forces are acting in a straight line, in a line such that the magnitude of the resultant of the magnitude of 2 means sum of two forces is equal to the third force, and the third force should be acting along the opposite direction. These two cases, in these two cases, a particle can be kept at rest. A particle can be kept at rest. Let me write solution. Acting on it. A particle can be kept at rest by three forces. Three forces acting on the particle, acting on it. If the three forces can be represented in, if number one case, suppose if number A, if the three forces can be represented in magnitude, and direction, by the sides of a triangle, taken in order, by the sides of a triangle. If the three forces can be represented in magnitude and direction by the three sides of a triangle taken in order. Number 1 A. And number B, the three forces should act in a straight line. Number B, the three forces should act in a straight line. Straight line such that in such a way, act in a straight line such that the sum of the this is magnitudes. These are magnitudes. Sum of the two forces. If I write two forces, means the sum of the magnitudes of two forces. Of two forces. Sum of the magnitudes of two forces acting in one direction. Acting in one direction should be equal to the magnitude of the third force acting in the opposite direction, in the other direction or opposite direction. What we have written here, a particle can be kept at rest by three forces acting on it if the three forces can be represented in magnitude and direction by the sides of a triangle taken in order. Number 2, the three forces should act in a straight line such that the sum of the magnitude of two forces acting in one direction is equal to the magnitude of the third force acting along the opposite direction. Answer number 1. 459. Answer is yes. Because magnitude of 4 and 5, 4 plus 5 should be equal to 9, is equal to 9. They are acting along a straight line. 4 and 5 are acting in one direction, and the force 9 is acting in the opposite direction. 4 and 5 are acting in this direction, and 9 is acting along this direction. The three forces are in equilibrium. 4, 5 and 9 by B. This is by B. The three forces of magnitudes 4, 5 and 9 can keep a particle in equilibrium. Number 1. Number 2. 4, 9, 15. Number 2. 4 plus 9. What is 4 plus 9 is equal to 13. Is less than 15. Means 2 cannot be applied. Also, no triangle can be constructed, because in a triangle the sum of any two sides is greater than the third side. No triangle can be constructed. No triangle can be constructed. Therefore, here answer is no. Answer of question number 2. This, it is no. It is yes. Number 1 is yes, and it is no. No triangle can be constructed. One is yes, 2 is no. 1 by B. Now Number 3. 5, 6, 7. Yes. Answer is yes. Why? A triangle can be constructed. A triangle, by the law of triangular forces, a triangle can be constructed by the 3 forces of magnitude this. Also, the direction should be also same to the sides of the triangle. 4, 6, and 7 forces of magnitude 4, 6, and 7 can keep a particle at rest, because a triangle can be constructed whose magnitudes are 5, 6, and 7, and the 3 forces should be represented by the 3 sides of the triangle taken in order. Therefore, by the law of triangular forces, the 3 forces can be in equilibrium. Number 3 is yes. Number 4. 4, 7, 9. Yes. It is also yes. By A. Why? A triangle, it is also by A. Number 3 also by A. A triangle can be constructed. 4 plus 7 is greater than 9. 4 plus 7 is greater than 9. A triangle can be constructed. By the law of triangular forces, these 3 forces can be in equilibrium. Number 5. 5, 7, 15. No. 5 plus 7 equal to 12. It is less than 15. No triangle can be constructed. No triangle can be constructed. No triangle can be constructed. Therefore, it is no. Number 6. 3, 17. Yes. Answer is yes. Why? 3 plus 7 should be equal to 10. 3 plus 7. This is equal to 10. Therefore, by B, it is yes. It is yes. Can keep at rest, because 3 and 7 are acting in one direction. In a straight line, 3 and 7, the resultant of 3 and 7 is 10, and the third force 10 is acting in the opposite direction, in the same straight line. Therefore, it is yes. Perhaps you have understood this one. Dear students, I want to stop here. Thanks for attending my class. Thank you very much.